Hello students, welcome back. Today we will be seeing Spectroscopy Part-3, numerical based on NMR, UV and IR data for structure determination of organic compound. So let's begin. So the problems of structure elucidation for simple organic compounds using spectroscopic technique. In this, UV, IR, NMR and mass spectroscopy data will be given to us, and based on that we'll try to elucidate the structure of the organic compound. So let's start. So let us begin with the first one, that is an organic compound has a molecular formula C8H10O and determine the index of hydrogen deficiency and deduce the structural formula for the following data. The data is given to us. They have given the IR spectrum data, that is 3500 centimeter inverse, 1600 centimeter inverse, and then they have also given us one, this should be 1570. Okay, 1570 centimeter inverse, then 710 and 716 centimeter inverse. So these are IR data they have given. Similarly, PMR or NMR data they have also given us to us. Okay, and they have given us the molecular formula. They have already given us molecular formula, that it is C8H10O. Now if you neglect oxygen, number of carbon are 8 and hydrogen are 10, so which we represent by X and Y for the formula of index of hydrogen deficiency. So index of hydrogen deficiency is given by the formula. This formula is very important. Okay, it is 2x plus 2 minus y upon 2. So students, you have to write this formula, then only you will get marks, because if you are going to solve this step by step, each step has marks. So this may have 1 mark for writing the only formula. So index of, because they asked in the question, you have to determine the index of hydrogen deficiency. So index of hydrogen deficiency is equal to 2x plus 2 minus y upon 2. So just remember this formula, where x indicates number of carbons and y indicates number of hydrogen. Now if you substitute the number of carbons and hydrogen in the formula, we get 2 into 8 plus 2 minus 10 upon 2, which comes out to be 4. So what does 4 indicates? 4 indicates the unsaturation. Okay, what does IHD indicates? It indicates unsaturation. So unsaturation may be 4 double bonds or 1 ring system and 3 double bonds. Okay, it may be what? How the 4 unsaturation may be present in your compound: 1 ring system and 3 double bonds, or all 4 double bonds may be present on the this molecular formula. Now using the data which they have given us, using the signals or the spectrums, we have to guess what is the structure. Okay, we have to elucidate the structure. Now elucidation of the structure means actually it is same like your jigsaw puzzle. So part by part we have to find out what are the groups present in the molecule. For example, from IR spectrum, what are the things we can find out? That 3500 centimeter inverse indicate it may be OH stretching may be there, means OH group may be present, and as molecular formula says, oxygen is present. So this 3500 always shows for OH stretching. Okay, then next is 1600 centimeter inverse and 1570 centimeter inverse, may be because of the aromatic ring C double bond C stretching. Then similarly 710 and 760 centimeter inverse indicates for CH aromatic ring stretching. Okay, it is CH aromatic ring stretching. Now this is the data from where we come to know that there is a aromatic ring. Okay, there is a aromatic ring present, because they are saying that these two indicates double bonds, so it may be like a benzene ring. Okay, and CH bonds, because 1700 710 and 760 indicates your CH bonds this way. Fine. Then next what they are saying, it also contains one OH. So let us prepare the groups now. Now then we have to connect all these groups, small part. They are saying there is a OH stretching, so OH bond group is also present. Now using PMR data, let us find out which are the other groups. Now when they say 3 hydrogens doublet, 3 hydrogen doublet, that signal is at 1.6, indicate what? 3 hydrogen, means this must be because of CH3 group, and it is showing doublet, means its adjacent group may be CH group. Okay, CH3 will show doublet only if it has one hydrogen or one proton adjacent to it. So here you will find that it has CH3 CH. Then next is what? Next is 4.2, one hydrogen showing singlet. So there is 4.2 indicates, because this value is higher, means de-shielded proton showing singlet. So this may be because of the OH group. The OH proton may show this signal. Hydrogen will show singlet because it is attached to oxygen. The next is what? 4.9 singlet. Quadrate. One hydrogen showing quadrate. Now this, that indicates what? CH group, which is adjacent to, because it is saying that it is quadrate, means because of this. See, this one hydrogen is going to show the signal quadrate because it is attached to CH3. So this hydrogen will show 4.9. Now if you see the value of 4.9, it is really great, means higher value, higher side of the chemical shift. 4.9 delta shows high value. That means it must be attached to some of the electron withdrawing group. Okay, this group should be attached to the electron withdrawing group. That's the reason why you are getting 4.9 delta value. Okay, so here, then next is what they have in PMR data, it is 7.45 hydrogens multiplate. Now whenever it is, students remember, whenever PMR value shows the delta value 7.2, 7.4, 7.5, something like this, means greater than 7 until 7.5, it indicates the hydrogen of benzene. Okay, and this benzene hydrogen shows, or proton show multiplates. So they are saying there are 5 hydrogens which is showing multiplate. So this may be the structure, and it must be the aromatic ring must be substituted one, because they are talking only about 5 protons in benzene ring, which is showing 7.4 value. Okay, so this, now if you try to solve the puzzle like jigsaw puzzle, here you are going to attach all these and try to find out whether it is going to match our molecular formula. Okay, so now this CH is there, so this is this group which we attach here, CH, then CH3. Okay, so see the valency of carbon here, this carbon shows only 1, 2, 3, 3 valencies. So obviously this OH group now which is left should be here on this carbon. Okay, and this way if we see the compound, we may get this as a compound. Okay, so let us draw the compound properly and see. Now let me just clear this first so that I can show you the proper compound. Okay, so this is how you have to determine the structure of organic compound using the given data. So let us see, this is the structure which we get, where a benzene ring, CH, CH3, OH. Now each value of PMR and IR spectrum I have written here. So if you can see the benzene ring, all proton shows which value? 7.4. Then this CH shows 4.9, as it is directly attached with the benzene ring and near to oxygen, so it will show de-shielded proton. This proton is de-shielded. Similarly, let me take the highlighter. This proton which is directly attached to oxygen, the alcohol proton, will show 4.2 singlet. Okay, again it is de-shielded, so it has 4.2 higher value. And CH3, that is these 3 protons will show 1.6 doublet because it is attached with CH. Okay, so this way we can elucidate the structure. Now let us see whether it matches our molecular formula. Let us count the number of carbon. 1, 2, 3, 4, 5, 6, 7, 8, 8, C8, correct? Benzene ring 6 carbon, 7 and 8. So carbon of benzene molecular formula are matched. Now let us count the hydrogens. They are saying in molecular formula 10 hydrogens. So whether in our formula which we have elucidated, does it have 10 hydrogen? Let us count. These 5 hydrogens of aromatic ring, 5, 6, 7, 8, 9 and 10. 10th is OH1. Okay, so there are 10 hydrogens, so it has matched, and 1 oxygen. And we also on the structure we have 1 oxygen, so our structure which we have found is correct. Okay, this way you have to try to find the structure and try to see the molecular formula also whether they matches with each other. Okay, so this is how you have to solve the uh, problem based on IR, UV and NMR data. So this is what our structure we will get. Okay, that is a benzene ring, CH. This CH is attached with COH, and we already saw that CH should be attached with CH3 group. So when you try to join all the groups which we got from the data, we can connect them properly and try to find out the structure. So the structure we will be getting is this, that is a benzene ring attached with CH. Then to satisfy the carbon valency, the carbon should be attached with COH group, and this carbon, which I will just highlight those carbons. Okay, this carbon should be attached with CH3 group because this proton is showing quadrate, means this proton should be near to CH3 group. Okay, then this OH was showing us 11.8, that indicate that it was directly attached with the oxygen, because 11.8, as I told you, it is highly de-shielded proton, so directly attached with the oxygen. And IR value was also showing 1300 and 3100 centimeter inverse. That means it is directly attached with COH group, electron withdrawing group, C double bond O group, where IR value shows 1715 centimeter inverse, correct? So this way if you try to write all the data and try to join all those groups which we are part groups which we try to elucidate from the given data, this is the structure. Now just we have to count the number of carbon in the molecular formula whether they are matching. So let us count. On benzene ring there are 6 carbon, 7, 8, 9. So C9, yes, C9 is correct. Now number of hydrogen, these 5 hydrogens, 5, 6, 7, 8, 9, 10. 10 hydrogens. So this is also matching, and there are 2 oxygen. So in our carboxylic acid group, 2 oxygen. So this way our molecular formula is correct with our structural formula. So our structure is correct. We have elucidated in a proper way because all our data is matching. Even the structure which we have determined is coinciding with our molecular formula. Okay. Now the next one is, an organic compound has a molecular formula C7, C4. Okay, this is C4, H7, Br, O2. Determine the index hydrogen deficiency and deduce the structural formula. So they are given you IR data and PMR data. Now let us begin. The formula is what? You will be replacing this by okay. So if you see the molecular formula, it is C, what it is? C4, H7, Br, O2. Okay. Now we know that IHD index is 2x plus 2 minus y upon 2, where x we say that it is what? Number of carbons, number of carbon, whereas your Y is number of hydrogens, but here if you see number of hydrogens are 7, and one bromine is there. So we always neglect oxygen. Oxygen we don't consider, but if apart from oxygen, if there is other atoms like halogens, okay, halogen or nitrogen, sulfur, then we have to add them in Y value. We have to add the number of atoms. Any atom other than oxygen, we have to add it in Y value. So Y here it is 7 and one bromine. Okay, one bromine. So we will be adding in Y value. So Y will be equal to 8. That's the reason why I have shown here Y is equal to 8. Now if you substitute it in IHD value, what you will get? 2 into 4 plus 2 minus 8, because your formula is 2 into how many C are there? 4 plus 2 minus 8, Y is 8, okay, upon 2. So if you calculate, it comes out to be 1. If you calculate this and see, so your IHD index comes to be 1. Okay, what does 1 indicates? 1 indicates that it is having only one unsaturation present in the compound. So one unsaturation means what? One unsaturation indicates that one double bond is present on your compound, okay, or one ring may be present. Either one ring or one double bond may be present in the given compound. Now if you see the IR data indicates that it is having what? 3000 centimeter inverse to 2500 and 171715. So 1715 indicates what? 1715 indicates carbonyl stretching. Okay, 1715. Remember always IR data 11715 always indicates carbonyl stretching. Okay, carbonyl stretching. So next, let us see what is your PMR data. PMR data indicates that 1.08, which they have given 3 hydrogens. So now you can guess 3 hydrogens means they may be because of CH3 group showing triplet. Triplet means it should be next to CH2 group. 3 protons showing triplet, that means the neighboring carbon must be having 2 hydrogens. Triplet, the formula is n plus 1. So n plus 1, if it is 3, that means n should be 2. So CH2 group must be present. Okay. So CH3 should be adjacent to CH2 group, that indicates. Now next data is what? 2.07. Okay. What does 2.07 indicates? 2 hydrogens having multiplate. So these 2 hydrogen may be showing multiplate because it must be attached with some other group near to it. So it might be CH group may be present, or if CH was there, and then they would have written quadrate, but they have not written quadrate. Means the indication is there must be a CH2 group. This proton is showing multiplate. Multiplate why? Because 3 plus 2 5, 5 plus 1, using n plus 1 formula, 5 plus 1 is 6, and if it is 6 or more than 5, we write it as multiplate. Okay, so 2 hydrogens are showing multiplate, that is these 2 hydrogens may be showing multiplate. Then next is what? One hydrogen showing triplet. One hydrogen showing triplet. Okay, so there must be CH group which is attached to CH2 group. Okay, one hydrogen showing triplet. So that, and they are telling that it is 4.23. 4.23 indicates what? That it is having some electronegative group attached to it, near to some group which is attached to your electronegative group. Okay, so that may be because of CH group which is attached to some electronegative group. The next is 10.95. Now whenever it is 10.95, 11, more than 10, that indicates what? OH stretching. Student, remember, 10 more than 10 delta value indicates CH stretching. OH stretching. Okay, so when it is saying that one hydrogen showing singlet means this hydrogen will show obviously singlet. It is directly attached with oxygen and highly deshielded. 10.9 indicates it is highly deshielded. Now let us solve the puzzle by connecting all these data which we have got. Okay, let us join all these groups and find out what is the structural formula part by part, because what are the things we got just now? We got CH3, CH2, CH and OH group. Okay, so these are the things which we have got. The molecular formula they have given is C4H7Br. C4H7Br. There are 4 carbons and there is one double bond. One double bond may be because of what? When we have got our IHD value 1. Okay, IHD value is 1 means one double bond, that is because of the carbonyl group. Now let us join all these groups which we have got. CO, what are the groups we have got? We have got we have got C double bond O group, then CH3 group, one CH2 group, and there is bromine also. Okay, so if we join all these groups, let us see what is the structure we can get. So let us solve this. So this is how you will be getting your structure, that is CH3, CH2, CH, okay, C double bond O, OH and Br. So here you will find that it is showing what? If you connect all these and try to see, try to validate with our data which we have got. So there are 4 carbon. So 1, 2, 3, 4 carbon. Okay, it is showing 4 carbon. 1, 2, 3, 4, which is also given our molecular formula. Then there are 7 hydrogens. So let us count whether 7 hydrogen we are getting by joining all these groups which we got. 3 hydrogens on CH3, then 2 means 5, 6, 7. So it is matching our molecular formula. Then there is a Br group which is attached with CH, and there are 2 oxygens which are on the carboxylic acid group. So this way we have elucidated our molecular formula for the structure for the given numerical. Now the next one is an organic compound has a molecular formula C4H8O and IR and PMR data is given. In the similar fashion, first thing what you will be doing, you will find out IHD value. Now IHD value will be equal to number of carbon and hydrogen. There is no other atom other than oxygen, so we will directly take the values as X is equal to 4 and Y is equal to 8 from the molecular formula. Now if you substitute it in your IHD value, then IHD formula you will be getting as IHD is equal to 1. So in the previous numerical also we saw when IHD is 1, that indicates 1 unsaturation. Either it may be a ring or double bond. Okay, unsaturation IHD is equal to 1 indicates either it is one double bond or one ring may be present. Now what are the other data they have given? IR data they have given that 1740 centimeter inverse sharp band. So 1740, 1715, all these indicates the stretching for carbonyl group. Okay, 17, it is from 1715 to 1750. This indicates for carbonyl stretching, C double bond O stretching. Okay, so C double bond stretching is present. Then next, so this double bond is present, one single from IHD value it is only one unsaturation, so that may be because of this carbonyl group. Okay, then let us find out from PMR data. 1.1, 6 hydrogen showing doublet, 6 hydrogen showing doublet. Okay, so doublet may be because of 2 CH3 groups. What it may be? 2 CH3 groups attached to, I'll just change the color of the pen, 2 CH3 group attached with the CH this way. if it is in this fashion only, then these 6 hydrogens will be having same environment because they are directly attached to the carbon. This CH3 or these protons are having neighboring one carbon and hydrogen. Similarly, this CH3 is also having in its neighbor one carbon and one hydrogen. So these two CH3 groups are having same environment. That's the reason why these two CH3 groups, that is 6 protons, will show doublet because of this one hydrogen, okay, in its neighbor. 6 hydrogen will be showing doublet because of this single hydrogen in its neighborhood. Understood? Then next it is one proton showing multiplet. So this is one proton which will show multiplet because its neighboring 6 protons are there. So this single proton, that is CH proton, is attached with how many? 6 protons. Okay. So this will show multiplet. Why? 6 plus 1, that is 7 signals it will be. 7 peaks it will be showing, this single hydrogen. Single hydrogen will show 7 peaks. Similarly, 9.4 doublet shows, see, even though this value is 9.4, it is de-shielded value. Okay, de-shielded value means a proton must be attached with some electron withdrawing group. But it is not more than 10, means it is not directly attached with oxygen. So, and it is saying that it is doublet. Doublet means C double bond O H, and this will be attached with this hydrogen, okay, this way, and CH3 and CH3. If you connect all these dots, you will be getting this structure. So let us see whether our structure is correct or not. What I have done, I have tried to connect all the dots which we got from the data. So 9 and 9 value indicates in PMR that it is aldehydic hydrogen. Okay, aldehydic hydrogen. The hydrogen, because of aldehyde group, will always show the value of chemical shift more than 9. So let us see the structure. This is what you will be getting the structure. Okay, this is how you will be getting the structure. Now one thing, I think there is a mistake what they have done here, that this they are saying it is a singlet, doublet, but this cannot be a doublet, it should be correct, it is doublet only, because this hydrogen is next to this carbon which is carrying hydrogen, and because of this hydrogen, this is correct, this hydrogen is in, that is, this hydrogen is in neighborhood of this hydrogen. Okay, that's why it will be showing doublet. Correct it is. So this way we have elucidated the formula. Now let us see whether it is going to match with our molecular formula. Let us count the number of carbon. 1, 2, 3, 4. 4 carbon, yes. Hydrogens, 3 plus 3, 6, 7, 8. So 8 hydrogen, it is also correct, and 1 oxygen. So our molecular formula is matching our structural formula. Okay. So let us go to the next one. An organic compound has a molecular formula C4H8O2. Okay, and in the similar fashion we have to do it. Now I will not read all this. So IHD value we can calculate because there is no other atom other than oxygen. So first thing we have to neglect oxygen and find out how many X value and Y value. X is, here X is equal to 4 and Y is equal to 8. So you can just substitute the value and get the IHD value of using the formula. IHD comes out to be 1. 1 indicates 1 unsaturation. Okay, you have to write down 1 unsaturation may be present. Now let us see the remaining thing, that is IR data they have given and PMR data. From IR data they have given it is 2980. Now 2980 indicates CH stretching. Okay, 2980 indicates CH stretching. Similarly 1750, now up till now you must be clear, 1750 indicates carbonyl stretching, C double bond O stretching, okay, of carboxylic acid group. Then 1065 indicates what? CO bond stretching. 1065 indicates CO bond stretching. So you have to remember all these values, student. Even though if you don't know one of the value, it's okay, but at least most of the values which are commonly asked, those you should know. Like 1750 is many times repeated in your numericals. 1065 also you should know, it is because of C single bond O stretching. Then let us see the PMR data. PMR data says that it is 1.17 3 proton triplet. 3 proton triplet means CH3 should be attached with CH2 group. Then only this proton will show triplet. Okay, this proton will show triplet if it is attached with the CH2 group. Then 1.96 3 proton show singlet means CH3 group should be attached with some group which doesn't have any proton on it. That indicates what? This 1.6 indicates CH3 group attached with some carbon or some other group which does not have any proton. Okay, the next value is what? 4.07, 2 hydrogen showing quadrate. So there is CH2 showing quadrate. Quadrate means it must be attached with the CH3 group. Then only it can show either CH3 group or there must be two CH2 groups. Then only it can show quadrate. Okay, either CH and CH2 group on both the sides or only single CH3 group. So let us see now using our molecular formula whether we can connect all these dots and find out whether the molecular structural formula what we will be getting. They are saying there are 4 carbons. So all these data if we connect and find out what is the structure. So see here students, there are 4 carbons. So one CH3 group which is showing singlet. See here, this was the data which we have seen, that 3 hydrogens which is showing singlet. So the CH3 group showing singlet because it is directly attached with C double bond O, which we got it from IR data. IR data says there is C double bond O stretching. So we have connected this CH3 group to this C double bond O stretching. Then we had one more clue. They have given that it is 4.072 hydrogen showing quadrate. 2 hydrogen showing quadrate will be, and that also 4.7 is de-shielded one. De-shielded means it must be attached with the group which is electron withdrawing. So this CH2 is directly attached with the oxygen. Okay, so it is showing de-shielded signal and showing quadrate means 4 peaks will be there. There will be such 4 peaks. Okay, shown by the CH2. Then there is CH3 which is showing triplet. CH3 is attached to CH2, so it will show triplet. Okay, in this way we have elucidated the structure of molecular formula C4H8O2. Okay, and if you count the number of carbons, hydrogen and all these things, they are going to match. There are 4 hydrogens, so 1 2 3 4 hydrogens, 2 oxygen, and let us see, sorry, 4 carbon, hydrogens are 3 plus 3 6 7 8, 8 hydrogens. So they are matching our molecular formula which they had given. Okay, now let us go to the next one. Okay, students. So these are what few numericals based on IR, NMR, and UV data which we have seen today to determine the molecular structural formula from the molecular data, molecular formula and the data given using the signals or spectrum. Okay, so do solve such type of numericals which are commonly asked in many of the exams, even in entrance exams like NET, SET, such questions are asked. They give you the data and you have to find out the structural formula, or structural formula will be given and the data is given. You have to find out uh, which will show the signal, which group is going to show the signals, which according to the data. Okay, so stay tuned. If you like the video, please do subscribe and like the channel and share it to your friends. Okay, till then, and if you really like this video and you want more numericals solved for you, please comment below. Okay, I'll try to solve many other numerical based on NMR and UV and IR spectra. So till then, bye, see you tomorrow.